All right, hello everybody. We were working recently with exponential functions, and specifically, if you have two random points, how can you find the equation of the exponential function that goes through those points? So I'll start with a really simple example, and then we'll do a couple more and build up to a little bit more complicated examples. So let's say we start with a point of 0, comma 2, and then we go to a point of 1, comma 6. And we are told that this is an exponential function. I want to be clear that if we don't know that this is exponential, then there's an unlimited number, an infinite number of functions that go through those points. Like, for example, it could just be 4x plus 2. Or it could be a quadratic, or it could be a sine graph, or it could be anything. But if we are told that this is exponential, then there is really only one function that goes through those points, and that is the function that has a y-intercept of 2, and see how that goes through the y-intercept there, y equals 2, and then multiplies by 3, see how that goes to the second point, raised to the x. And what that's showing is that for every one step that you take to the right, you go 3 times as high. And so I know that, for example, this point right here must be at -1, comma 2/3, because this point right here is 3 times as tall. And if I go one more step over to the right, then I'm going to be all the way up there at 2, comma 18, because that's 3 times as tall. Okay? Yeah. All right, so that's the simplest example. And what's simple about that is you have the two pieces of information right there given to you as your 2 points. We're going to be writing it as the y-intercept and then the multiplier raised to the x power. So this is going to be your y-intercept, and then this is going to be your multiplier. Sometimes people will also call it the factor. I kind of like using the word multiplier because right in the name, it tells you what it is. It's the thing that you multiply by. Okay, so let's do a couple more examples then where maybe we don't know one of those pieces and we have to work backwards to figure it out. So let me delete this. Oops, of course, I deleted everything. All right, so let me give you a different example. Let's say I had the point 1, comma 12, and let's label that. And then we have the point 2, 2, comma 4. I got to zoom out a tiny bit so I can see that first point. So when I look at this here, my multiplier, remember we had y-intercept and multiplier. My multiplier is always the later y value divided by the earlier y value. And I'm going to put a little, this is almost correct here. This is my multiplier when I'm moving just one step to the right. Okay, so I'm going to just make that really clear that I'm moving just one step to the right. I'll put a 1 right up there. And if I do my second y value divided by my first y value, I get my one-step multiplier is 4/12, which you can reduce to be 1/3. You don't have to, but you can reduce it. The tricky thing is, what's the y-intercept? I don't know what the y-intercept is. There's kind of two different ways you can do this. Method 1 is to just work backwards until you get to the y-axis. And method 2 is to set up a system of equations and figure it out that way. So here's one option. So option 1 is working backwards. So I know that at the point 1, comma 12, I have to move backwards one step to get to 0, comma something, right? I have to go backwards one step. So what do? I take 12 and I divide it by my b value. And I only need to divide it by b to the first because I'm just one step away from the y-axis. So if I do 12 divided by 1/3, that's the same as 12 times 3. And so I know that this number should be 36. You could have also done that using your other point, 2, comma 4, working backwards to your y-intercept. You take 4 and you divide it by 1/3, but you need to go 2 steps backwards. Remember I put this little 1 on the b value? that means that's your one-step multiplier. So if I want to go 2 steps backwards, I square it. And that would be 1 over 9. 1 times 1 is 1, 3 times 3 is 9, and so 4 times 3 also gets you 36. So that's one method, and then that gives us our y-intercept, and so we can type in our whole equation. Y equals 36 times 1/3 raised to the x power, and it connects those dots. Method number 2, some of you might like this method more, is to set up a system of equations using our 2 points. We know the b value is 1/3, and so we can use these xy points in our equation. We could set up 12 equals, I'm pretending I don't know the y-intercept, so 12 equals a times 1/3 to the first power. And my second equation, using y equals 4 and x equals 2, 4 equals a times 1/3 squared. And you can see how in either one of those equations, I actually really only need one of them, but in either one of those equations, I can solve for a. Here I multiply both sides by 3, and I get 36. Here I would multiply both sides by 3 squared, and I also get 36. So that's the same exact idea. Great. Okay, let's do one more example that's a little bit harder. So we'll do 2 points, and I'm going to make up these points. They aren't even going to have a nice multiplier. I'm just going to make up 2 random points. -1, 3. Let's put this one at 3, 7. So they don't have really anything in common with them. I'm just going to show that in general, you can always find the exponential that goes between them. So option 1 is by saying, all right, remember we're doing the a times b to the x. And so option 1 is saying that the b value is the multiplier. And earlier, I said it was the one-step b value. How many steps did I have to go here? 1, 2, 3, 4 steps over. So this is my 4-step multiplier. And I do 7 over 3. So when I went 4 steps to the right, I multiplied by 7 over 3. I know that if I go another 4 steps to the right, I'm going to multiply by another 7 over 3. If I solve that for b, I can write it like this. 7/3 to the 1/4 power. Or if you don't like that way of writing it, you can do the 4th root of 7/3. Then I need to figure out what my a value is. I could use either one of my points. I could say -1/3 going to 0, something means I'm using a single b. So I'm actually going to multiply 3 times b to the first power. And so I can't do that in my head, but I know that this number right here then is going to be 3 times the 4th root of 7/3, or 3 times 7/3 to the 1/4. So let's see if that gets us an equation that goes right through it. So our a value is what we just calculated, 3 times 7/3 to the 1/4. Okay, that goes through the y-intercept. And then our multiplier is 7/3 raised to the x. Oh, sorry, 7/3 to the 1/4, and then all of that gets raised to the x. Almost, there we go. There we go, now it goes through those dots. There's another way I could write that, which is I could write all of this the same, but instead of having a power raised to a power, because that is kind of annoying, I can multiply my 2 powers and make this, instead of 1/4, make this 1/4 times x, x over 4. And you can see that that red line goes straight through that. And there's one other way I could write that, which is instead of having these 2 copies of 7/3, I can write it as x over 4 plus, nope, 1 plus it, or 1/4 plus it. And that works because when you multiply two things with the same base, you can add the powers. So let me show you one last way to do it, and then we'll call it good on this video. The option 2, the systems of equations I was talking about, where you set up y equals a times b to the x using your first point, the y is 3, and the x is -1. Using the second point, your y is 7, and your x is 3. What you can do is you can divide these two equations by each other. So then I get 3 divided by 7, a divided by a is 1. When you divide with the same base, you subtract the powers. So -1 minus 3 is -4. That means that b is equal to 3/7 to the -1/4 power. And that negative power, this is just a nice reminder that the negative power is the same as flipping over the fraction. And that's the same answer we got before as our b value. We can then take that and substitute it in to either one of the equations. I'll just use the top equation. So 3 equals a times my b value raised to the -1. And you can see then that I have 3 equals a times 7/3 to the -1/4. And so if you multiply both sides by 7/3 to the 1/4, it switches sides of the equation. And you can see how that's the same a value and the same b value that I got. So anyway, in this video, I just tried to show you examples that got a little bit harder of finding exponential functions that pass through any two random points. Let me know if you have any questions.